Okay, so quickly I want to show you how to connect nodes in a singly linked list. So we have these three nodes. We have this node with the value 300, this node with 100, and this node with 200. So I want to connect three of them. Okay. Now notice that every node has an address. Okay. Node C rather has 1024 as its address. Node A has 20,024, and then node B has 30,034. Okay, so how do we connect these three nodes? Node C to node A, and then node A to node B, So our expected output is this: C pointing to A, or rather C connected to A connected to B. And then notice this B connected to null. Why? Because the last node in a singly linked list must always point to null. In other words, a null address. Okay, so if you look at this other diagram now, they are connected here. This is our output. Okay, so what is the difference between this diagram and this other diagram? The difference is that if you look here, where the address of this node is now here, and I'll tell you what this is. The address of this node is also inside this other node. Now, here is the explanation. Every node has the data part and the link part. So I say it again. I said that every node has the data part and then the link part. So for node C, the data part is 300, and then of course the link part is reading 2024. And of course every node has its address. So this is the address of this node. So it has address, it has data part, and it has link part. This part is the part where it links to this other node. This other node has address 2024. For this node to link to this node, it has to be connected through its address, you see. So the link part of this node must carry the address of this other node. The link part of this node must be pointing to the address of this other node. Likewise here also, the link part of this node must be pointing to the address of this other node. That way, they all will be connected together in this order. And then the link part of the last node in a singly linked list must be pointing to a null value. That is how you know that that is the last node. Okay, so this is a singly linked list. So this first node is called the head. Okay, this last node must point, the link part must point to null. I said that is how we know that this is the last node in a singly linked list. Okay, so I'll quickly, having explained this, okay, how to connect the nodes, that the link part of one node must point to the address of the other node that is to be connected to. Okay, so in summary, the link part of node C is pointing to the address of node A. The link part of node A is pointing to the address of node B, and the link part of node B is pointing to null. That's how we get our output: C connected to A connected to B connected to null. Okay, so let us quickly implement this in the C programming language. Okay, so this is our expected output: C to connect to A to connect to B to connect to null. Okay, so the trick here is that I said that every node must have what? Every node must have the data part and the link part. Every node must have data part and the link part. So the first thing we will do here is to declare the structure of the node itself. Okay, to declare the structure of the node. Okay, so in C, you declare the structure like this: struct node, and then open parenthesis, close parenthesis. So the data part, of course, is an integer, so we declare that here. And then we have the node part, which is also going to be declared with the same name as this structure. So node, rather, struct node pointer next. Okay, so struct ends with semicolon in C, And then the next thing is that we'll declare the 3 nodes just to initialize them. So of course they have struct data type, so we'll say struct node pointer A, pointer B, and then pointer C. Okay, so for us to be able to connect C to A to B, we have to get their addresses. Okay, so the first thing we want to do here is to get the address. Then the second thing, we will pass the values. We'll assign the values 300, 100, and 200 to the different nodes respectively. Okay, so to get the address of node A, we will say A. In C, we use malloc or malloc or mloc, as you would like to call it, and then you say size of struct node. Okay, so remember that A was declared as the node, or rather as the struct data type. Okay, so this will return the address of A, and so to get the address of B and C, we'll just do the same thing. Okay, so just change this to B, and then change this one to C. Okay, so that's the first thing there. Then the second thing I said, assign the values. So the data part of A here, the data part of A is 100. So the data part of A is assigned 100. Okay, the data part of C is 300. The data part of C, sorry, I have a mistake here. The data part of C is 300. Okay, then the data part of B, the data part of B is 200. Okay, are we correct? Let's confirm. Okay, data part of C 300. Okay, data part of A 100, data part of B 200. Okay, so we're correct there. Okay, so now that we've gotten the addresses of A, B, C, and we've assigned the values 100, 200, and 300 to the data part of A, B, and C, the next thing we want to do is to point them together, or rather to connect them together. Okay, so I said that in this problem we're solving, we're asked to connect C to A and A to B. Okay, so the link part of C, just the trick here is this. Since this is what we're asked to do, C to connect to A to connect to B, and B to connect to null, maybe you should always write it out in this format first. What should connect to what? The trick for me is that when I write it out in this format, and of course I put these pointers like this, so already then I know that in the code C next is assigned A next is assigned B next is assigned null. If you do that in code, you have connected them. So I say the trick is, so I say C next, because we're using next in this code to represent the link part of each of the nodes. Okay, so I say the link part of C. That's what I mean by C next here in this code. So I say C next is assigned what? The node A. Okay, so I've connected those two. Then I say B next just as, or rather, from this our diagram here, the next thing is not B next, the next thing is A next, okay, is assigned what? B, and then B next is assigned what? Null. Okay, so I said that the trick is, if you write it out like this, you know, to help your visuals, so you see what is connected to what, and what is connected to what, and what is connected to what, and in code just simply write them in that manner. Okay, C next connected to A next connected to B next connected to null. Okay, so to print it, to print the linked list, let's assign the first node here, which is the head node. In linked list, the first node is called the head node. Okay, let's assign the head node to a temporary variable here. Okay, so we'll declare a temporary variable of the data type struct temp, and then we'll assign C to it, because C is our head node, the very first node here. Okay, while we're doing this, I want to use temp here as a traversal. Okay, I want to use it to traverse from C to A to B, and then B to null, so that I can print all the nodes. Okay, so how do I traverse? I now say while temp is not equals to null, okay, because actually if temp is equals to null, then two things will hold: either our linked list is empty, doesn't have any node, or the program has gotten to the end of the linked list, because we said that the very last node always points to null. Okay, so that's why we say while temp is not equals to null. Okay, now if C in itself is equals to null, it means there is nothing in our linked list, no nodes in our linked list. Okay, so as far as C is not equals to null, or we have not reached the last node, since the last node is pointing to null, do what? Print each data. Okay, so we say temp each node's data. Okay, so we say print f. So we say print f percent d space comma temp data. So print each data. Okay, print each data of each of those nodes, and then point, and then move to the next node. So I'll tell him here, after you print one data, move to the next node. So what does he do? He gets to C, he checks, is C equals to null? No, C is not null. C is having a node that is carrying a data and an address. Okay, so what does he do? He prints the data of C, and then this second instruction tells him, after you do that, move towards A. Okay, do the same thing if A is not equals to null, because once he moves to A, control goes back to test if temp is equals to null. If it is not, it will enter the block of code again and do what? Print what? Print A. and then move to the next node after printing A. So now it arrives at B, and then it goes back to test the condition. Is it null? No, it's not null. The node is not null. Okay, so it continues. It enters inside and prints what? B. And then it moves to the next node, and now the next node is actually null. So when it goes to the while loop to test, it finds that it is null. What does it do? It comes out of the while loop, and then here we're finished. So we just say return 0. Okay, so let's see if let's test the code we've written to see if there are any errors. Okay, so I forgot to put node here, so I compile again. Okay, so all test cases passed now. Let's just see what was here. So test case 1, input is nil, expected output 300, 100, 200, actual output 300, 100, 200. Okay, so our code worked. So okay, so this is how you connect nodes in a singly linked list. Thank you. If you like the video, go ahead and subscribe, the red button below this video, because we're going to be doing this as a series. More videos on linked lists are coming soon. That way you can't miss a thing. Thank you.